So in the problem of the lift, you saw that the lift was going in the downward direction. Okay. Now acceleration due to gravity, that is also in the downward direction. So the acceleration of the lift and the acceleration due to gravity, they both are in the same direction. So we added them to find out the resultant, right? But now we are dealing with the rocket. Okay. So the rocket is moving in the upward direction. So the acceleration is in the upward direction. And acceleration due to gravity, that is always in the downward direction towards the earth. So at first you have to select which one you are considering positive. If you consider the upward direction positive, then A will be positive, but G, it will be negative. So the resultant, you see, it is always A plus G, but it depends on the value. Let us say A we have considered positive, so it will be positive, then plus minus 9.8, right? So plus minus, it becomes actually minus. Okay, that is why it is A minus G here. Here in this case, if you have to find out the resultant acceleration, then you have to subtract. বুঝতে পারছো? Achha. Now in the result, they have found the resultant acceleration. The result of this is negative. That means the acceleration is in a downward direction. We have taken the upward direction to be positive. Our acceleration is negative. That means the acceleration is in the direction, is in the opposite direction, which we consider positive. We consider upward direction positive, the opposite to it is downward. So the acceleration is in the downward direction. As a result, what will happen? The rocket will not be able to move in the upward direction. To move in the upward direction, the rocket must have a positive resultant acceleration when you consider the upward direction to be positive. Do you understand my point? Buchha? Naki? Okay, fine. So 20, can I move to 2080 or 2070? There is something else to discuss.
24D.
Or 24D, acha. 24D also your message. Let me check. Acha. In 24D, I guess yesterday. Oh no, we started to discuss, but we could not finish, huh? Acha. So a thin uniform rod is there. Let me draw the thin uniform rod here. Okay. Of mass 1.75 kg, mass is equal to 1.75 kg. Okay. And length 25 centimeter. Total length 25 centimeter. Okay. Is rotating around the central axis. Central axis means the axis passes through the center or at the middle point of the star. Now in D, they are asking if the axis of rotation is at a distance 2/3 from one end of the rod, then determine its moment of inertia of radius of gyration. Okay. From one end of the rod, 2/3 distance. So if I consider this is one end of the rod, okay. So 2/3 of this distance, what it will be? 2/3 from one end of the rod, and then determine its moment of inertia. So 2/3 of 25 centimeter. It will be 50 divided by 3. So 16 point something. 16 point, how much it will be? Can you calculate 50 divided by 3? I guess
16.67.
16.67, right? Okay. So if you consider it this end, then from here, the new axis that we are considering now will be passing through here, and the distance is 16.67 centimeter. And then from the other end, it will be automatically, we can understand it will be 1/3 of 25 centimeter, right? Which will be 8.33. Okay. So this distance will be 8.33, making it 25 centimeter in full. So if the axis of rotation is at a distance 2/3 from one end of the rod, then determine its moment of inertia I and radius of gyration. Yes. Okay. 1 minute. Okay. So we have to calculate the moment of inertia, that is I, and the radius of gyration, that is K. Okay, for this situation. So let us see how to. বলো।
Two-third of ওটা বুঝছি, but 1/3 ওটা তো কোশ্চেনে বলে নাই।
হ্যাঁ, ওটা বলে না, এটা তো আমরা অটোমেটিক্যালি বুঝতেছি না। ওকে, 1/3 এটা যদি নাও বুঝো, তাহলে আমরা একটা জিনিস খেয়াল করো। If this distance is 16.67, total is 25, then 25 থেকে 16.67 subtract করলে কিন্তু 8.33 পাওয়া যায়। সো চাইলে এটা এভাবে বের করতে পারো। আর আমি যেটা বলছি যে মানে এটা যদি 2/3 হয়, তাইলে বাকি যে ডিসটেন্সটা থাকে সেটা 1/3। কেন বলো তো? কারণ এই দুইটা অ্যাড করলে টোটাল 1/2 পাওয়া যায়। দেখ এটা না বুঝলে অসুবিধা নেই। ওকে, এটা বুঝলে হবে যে মানে 2/3 16.67, দেন 25 থেকে এটা মাইনাস করলে বাকি ডিসটেন্সটা পাওয়া যাবে। ওকে
ওকে,
আচ্ছা। So here, if they have used the concept of differentiation, okay, we know that the moment of inertia, if I consider a very small portion here at the middle, let us say I have considered a very small portion, that is dx, right? So for this dx, it will be x square dm. The mass of this small portion I have considered to be dm, and the distance from the axis I have considered it to be x. Okay. So now if I integrate this one, then I will get the moment of inertia for the whole rod, right? So here differentiation, integration, they will balance each other. I like to remind it in this way. And here I need to actually put the limit. I will actually put the limit here. Okay. So before I put the limit, now did you understand this part, that how I replaced dm by m by l into dx? The mass of this smaller part can be represented in this way. This is the mass per unit length. See, mass divided by length. So mass per unit length into the thickness or the width of that part. So it will give us the mass of that part. Okay, if anybody is not understanding this one, please unmute yourself and let me know, or else I will continue. Okay, so integration and differentiation, they will balance each other, so it will be I, and here it will be m by l. These two are constant, the total mass and the total length, it will not change, right? But this x is changeable, right? If I consider this one, this portion somewhere else, then the value of x is going to differ. Okay, so if I do carry out the integration, it will be x to the power 2 plus 1 divided by 2 plus 1. If you remember this formula, x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. I'm asking again, if you're having any doubt in any of the line, please let me know. There are explanation for everything that I'm doing here. Okay, so try to understand. That will make it easier for you to remember all this calculation. Achha. Now we have to put a lower limit and upper limit here. Okay, what will be the lower limit and upper limit? If you consider from this axis, the upper limit is this distance. We have to go up to 16.67 distance. Okay, so the upper limit is 16.67, and the lower limit, it will be in the opposite direction, right? 8.33, so it will be minus 8.33. Okay, so understood. I think some of you might have faced this confusion while solving this problem. I think they have written a little bit wrong here. Okay, they put the lower limit as minus 16.67. Actually, they have converted converted this into meter. So if you want, you can also convert it into meter and do, no problem. Okay. Achha. Then it will be 3. So 3L M and it will be x cube. So 16.67 minus 8.33. So you will replace 16.67 in x once and then put a minus sign and minus 8.33 cube. Putting the upper limit or lower limit. This one I think you know already. I will show. I is equal to M by 3L 16.67 whole cube minus 8.33 whole cube. This is supposed to be the way. Okay. So here you can put the value of the mass. We have it. The mass was given as 1.75 kg. If you remember at the beginning of this stem, and the total length that is 25 centimeter. Okay. So you can just do the calculation and you will get your answer. Clear?
Yes.
You have to respond. Okay. Please, everyone, try to respond if in case you didn't understand at any line. I'm asking again and again. Okay. Achha, so I, let us say I have found out the value is known. Now this one, this I is equal to, we know that I is equal to mk square, where k is the radius of gyration. So m, if I change the side, it will be whatever the value I have got from here will be put and divided by the m. M means 1.75 again. So that will give you k square. To find out k, you have to do root over. Okay. So I have showed you the procedure that needs to be followed to get the moment of inertia and radius of gyration. If anybody have any doubt, please ask me now, or else I'm going to move to the next question. Anybody wants to ask anything? Sadia, Lamia, Tariq, Morshed,
No, sir.
Shihan, Nabi, Saiful. Anybody has any doubt?
No, sir.
Okay, fine. So the next problem that you have messaged me is 32D. Okay, so let us talk about 32D. In 32, if I read out the stem to you, at a circus party, a performer is rotating a 10 kg sphere with a 3 meter long rope. So 3 meter is the radius and 10 kg is the mass. Then and 1 meter above from the ground. Okay, that sphere completes 20 rotation per minute. Whenever RPM, rotation per minute, is given, you can calculate the angular velocity omega from it by 2 pi n by 60. Okay, the rope suddenly tore apart. Whole the sphere was still rotating. Whole na, while of
কোর মানে
eh?
না এটা মানে কি কোর এটা বলতেছিলাম স্যার কোর মানে কি
টোর মানে হচ্ছে টিয়ার। আমরা বলি না যে কোনো কিছু ছিঁড়ে ফেলা, টিয়ার অ্যাপার্ট, ওটার পাস্ট টেন্স হচ্ছে টোর, মানে ছিঁড়ে গেছিল, পাস্ট টেন্স।
ওকে
Okay, the rope suddenly tore apart, মানে ছিঁড়ে গেছিল। While, এখানে whole না, এটা হবে while the sphere was still rotating. The distance between the performer and the audience is 4 meter. আচ্ছা, distance performer থেকে audience distance 4 meter. Fine. Now, in D, either the sphere will hit any one of the audience or not. Explain your opinion mathematically. Now, in this problem, do you have any problem with any specific formula that they used, or you didn't understand the full solution?
full solution only
Full solution. Okay. So we need to actually calculate that after the rope gets snapped, okay, how much distance it will cover linearly. Why linear? Because till the rope was attached to the ball, you were serving a centripetal force on the ball, okay, through the rope, keeping it in a circular path. As soon as the rope tore apart, what happened? centripetal force got cut. As a result, there is no reason for the ball to be in rotational motion anymore, right? So as a result, what will happen? Now it will travel a linear distance, right? If the linear distance is more than 4 meter, then we can say that yes, it will hit an audience, right? Because the distance between the audience and the performer is 4 meter. But if the covered distance is somehow less than 4 meter, then we can say that it will not hit any audience. Now our target is to calculate the linear distance it will cover. How we can calculate? Let us see. At first, as I told you, that we can always calculate omega from what?
PM.
Rotation per minute, right? From that value, we can calculate omega. So let us do that. Omega is equal to 2 pi n by 60. So how many times it was rotating? 30 or 20? 20. Here it was 60. So 20 is 3 হবে. So it will have a 2 pi by 3. This is radian per second. Okay. Now this one we will use to calculate the linear velocity, as we know that V is equal to omega r, right? So omega is 2 pi by 3, and the radius of the rope was 3. So as a result, 3 will get cancelled. 2 pi meter per second. This is the linear velocity. Okay. Now this will travel like a brush, right? As they said that he was rotating the ball at 1 meter height from the ground. 1 meter height from the ground. Now as there is gravity, we cannot deny the gravity, okay? So if we could have denied the gravity, we could have said that the ball will travel in linear direction straight, right? But now it will travel a distance something like this. So what is the distance, horizontal distance or horizontal range that will be covered? If it is, we will compare it with 4 meter. If it is greater than 4 meter, equal or greater than 4 meter, then we can say that it will hit the audience. If it is less, then we can say that it will not hit the audience. So let us see how we can calculate. Acha. So if I want to calculate the linear distance, okay, x, let us say the linear distance is x, I need to get the velocity along x-axis, the dx naught into t. I have applied the formula s equal to dt here. Can anybody tell me why I will apply the formula s equal to bt?
Uniform.
Uniform velocity. Why I am considering uniform velocity along x-axis?
Because it is horizontally going toward farther.
Not the exact answer I'm looking for. Why there will be no change of velocity along x-axis?
So sir, সামনের দিকে যাইতেছে তো same velocity হবে, change হবে না.
See, the velocity we can resolve it into two perpendicular components. One along x-axis, one along y-axis. The velocity component along y-axis, this velocity will change. Why it will change and why the component along x-axis will not change? Why? I want to know. I have explained.
Zero.
Huh?
The along x-axis it is 0. No gravitation act. No gravitation act.
No gravity along x-axis. Gravity is a force that acts along y-axis only, right? So as a result, the velocity component along y-axis will change because a force is acting along y-axis. But along x-axis, acceleration due to gravity is not there. So no change of velocity will occur, right? Remember this one. I explained this one while discussing projectile. বাংলায় এটাকে আমরা crash বলি, আমরা বাংলায় পড়ে আসছি না তো crash বলি। তো ইংলিশে এটাকে বলে projectile. Okay, so the motion of projectile, we saw that the velocity along y-axis will be affected, but not the velocity along x-axis. Now you can see that the velocity component along x-axis that can easily be calculated. That is not our problem. Actually, the value of that is directly 2 pi, because the velocity is along x-axis. There is no component along y-axis. Okay, so the full, if you remember, if I have thrown it horizontally along x-axis, the full component is along x-axis. Along y-axis, there is no initial velocity. So this one can be known, but what about t? I do not know t. So I have to know t. That before it falls on the ground, that means before it covers a distance of 1 meter along y-axis, what is the time required? Okay, এই যে 1 মিটার নিচে আস্তে আস্তে ও যখন এই পয়েন্ট থেকে এখানে এসে নামবে, ও কিন্তু ভার্টিক্যালি 1 মিটার ডিসটেন্স কভার করে। তো এই 1 মিটার ডিসটেন্স কভার করার জন্য কতটুকু টাইম লাগবে, সেই টাইমটা আমরা বের করব। ওই টাইমে ও কতটুকু সামনে যাবে সেই জিনিসটা আমরা দেখব। এই টাইমে কতটুকু x ডিসটেন্স ও কভার করবে সেটা দেখব। এটা 4 মিটার হইলে তার মানে কোন অডিয়েন্সের গায়ের উপর গিয়ে পড়বে এটা। তো তাইলে আসো আমরা এটা কিভাবে ক্যালকুলেট করতে পারি। v, এই যে এখানে v যেটা, এটা একটু এখানে বলে রাখি যে vx নট এটাই হবে 2 পাই এবং vy নট this will be 0. Why this will be 0? If you remember, if I throw a body at a certain angle with the horizon, then there will be both x component and y component, right? But as I have thrown the ball in the horizontal direction only, so the whole velocity will be along x-axis and there will be no component along x-axis, right? So the initial velocity along y-axis will be 0 and the full velocity will be along x-axis. Acha. So to calculate the time, we will use this equation h equal to vy t, or we can write actually y equal to vy t plus half g t square. So now, as you can see, the vertical distance that is covering is 1 meter is equal to initial velocity. This is 0, so 0 into t plus half into 9.8 into t square. So in this equation, the only unknown is t. So if you find out the value of t, you will get it 4.452 seconds, 0.452 seconds. That means এখান থেকে 0.452 সেকেন্ডের মধ্যে এটা মাটিতে এসে পড়বে। তো মাটিতে এসে পড়তে যে টাইম লাগে, ওই টাইমে সে কতটুকু x ডিসটেন্স কভার করবে সেটা আমরা বের করব। তো if I put the value over there, x is equal to vx naught, which is equal to 2 pi into time, it is 0.452. So kindly find out the answer. Here I can see that the answer is actually 2.84 meter. So as it is less than 4 meter, it will not actually reach the audience. It will drop on the ground before it reaches the audience, so it will not hit any audience anymore. Did you understand?
Yes, sir.
Yes,
So
sir.
try this problem. Try to solve this problem at home. Spend some time thinking about this one. For them, it is very easy to understand when I explain. But for the people who did not actually try this at home and hearing from me now, for you it might be a little bit difficult. Okay, it's very natural, and you are the one who is responsible for this because you didn't do your part. Okay, I am doing here my part. You asked me out, I'm solving it, but you didn't do your part, then you are the one who is responsible for this. So please be serious. As I keep telling you again and again, HSC and SSC not the same. Huge difference, like the ground floor and the 10th floor. Okay. Okay. So with that, actually we have come to end of this chapter, Newtonian Mechanics. Alhamdulillah, Allah is the one who is to be praised. We have been able to finish this successfully. Inshallah, from the next class, we will start the chapter work power energy, inshallah. Okay. Okay. Nobody agrees with starting another chapter?
Yes.
Okay. Thank you very much. So before we end the class, anybody wants to ask anything? Nobody? Okay, so done. Newtonian mechanics finished. Okay.